Now, what happens if you have something that's non-ideal? Well, that makes what we call an azeotrope. And by definition, azeotropes are liquids that can't be separated by boiling. So in other words, there is some type of interaction between those two liquids that are keeping them in such a strong thermodynamic interaction that they're not going to boil. And so they're not going to get separated. And the reason for that is because actually they have this point on their temperature composition diagram where the vapor composition and the liquid composition is the same. And once you get to that point, you can't get past it anymore. And so this is just an example of a high boiling azeotrope and a low boiling azeotrope. So water and ethanol is a good example of a high boiling azeotrope. You have to go to a really high boiling point to get them to separate. Okay. Or rather, I should say their boiling point increases to get them to separate. Here, this would be more of a better example of like a non-volatile component or a component with a very low vapor pressure that's lowering the boiling temperature. Okay. So, but what's going to end up happening when you're doing this whole idea of like, boiling and then separating the mixture and boiling and separating and boiling and separating, it's going to hit this point now where the composition is identical of the vapor and the liquid, and you can no longer separate it at that point. Okay? So that's all that I really kind of want to say about azeotropes. Just recognize they're two liquids that can't be separated by boiling, and that's because they have this point on their temperature composition diagram where the vapor composition and the liquid composition is the same. And that prevents you from being able to separate these.